Hello, everyone. I think it's a good time to start. Welcome to our second day of the conference. First day of the conference was a big success. We had a lot of discussions, a lot of feedback from the audience, and a lot of engagement. And we found out a lot of questions and some answers for the questions. And yeah. So before starting the recap of the first day, I would like to go over a few important points for those who are joining today for the first time, or whoever missed the first part of the first day. So basically, if you missed something yesterday, you can revisit our website and you can see the recordings. Many talks was recorded, but for the recording we need to have permission. Some recording was not permitted. That's why please don't record yourself, and just use the recordings provided on our website. So today all the talks, most of the talks will be also recorded. So yeah, feel free to distribute it to your lab members, to your friends and all. And then another important thing is like we are running a Discord session. Discord session is like really important because we are building up community and all the contributions are important. There are no silly questions. There are no right and wrong in the embodied intelligence. All the opinions are counted and everything is important. So just please feel free to engage. Like yesterday, we was having a nice discussion related to the ChatGPT. Does ChatGPT have embodiment? It's a good question, right? So you can basically visit the Discord channel now, and you can read what people think about it, and you can continue the discussion in the similar way. Just use the QR code on your screen and join. So it works on all the platforms. So any technical issues and problems are also welcome. You can basically email us and get a quick reply, or you can put it in the Discord channel. Yeah, please, please be proactive in this conference, and it's very important. It's still getting online, so yeah. So main objectives. We are having like lots of discussions in this conference, and a lot of interesting topics are coming up. So one of them is like, what are the impacts and why impacts are important now? Cecilia last year was pointing out that soft robotics was growing up like really rapidly, but at a certain point it plateaued at a certain point. Will it go up or will it start declining? It really depends on the impact and will the industry take over the things. People have different opinions, and we are trying to figure out answers for those questions. How did AI change the last 2 decades? We see the great improvement in AI world, and how does EI and AI fit and complement each other? So a lot of discussions are going on about ChatGPT. Does this like large language models have embodiment, or does the embodiment important at all? This sort of questions are rising up. And how does the embodied intelligence research change in the last 2 decades? Do we have any progress? Did the biggest chunk of work in embodied intelligence was done in the early 2000s. So what do we have today? And do we have any answers for this sort of questions after the first day of the conference? And what we are looking for to answer in the second and third day of the conference. So please like have fun, and yeah, let's move to the recap session of the first day, and then enjoy our conference today. So basically, the first day was we was having like 3 plenary speakers. It is a really good lineup of speakers. I will tell you why very soon. And we also had two very nice sessions for the short talks. And what most important is that we was having a good panel discussions after those talks, where we raised important questions and we were trying to find answers. And not always easy to find answers for those fundamental questions, which you can also see in our recordings. Basically, the first day, why it was important to have this lineup of speakers, because we can clearly see the progress of the embodied intelligence. In the beginning, embodied intelligence was more bio-inspired, but these days embodied intelligence is like more bio-integrated. So we moved up one step ahead. Like Shoji presented biohybrid approaches. So he basically can grow muscles. He can build biohybrid sensors, actuators, reactors, and processors. He built the the finger with the muscle actuations and with the skin. It's like it's very impressive. And then he replicated smell perception that distinguishes very similar pheromones. And you can basically use this sort of sensors to rescue missions during the earthquake or other disasters that can really find human beings in the those kind of environments. Then detecting cancer cells from the breathe out gases, it's also very impressive. So we can really see that these days, like we can use the biological engineering into the robotics field. Ellen was presenting another side of the coin of the biointegration. So she was using robots to augment human organs. We know that like some of the organs are experiencing damages and failure. For example, she did like mechanical assistance of the respiratory ventilation. She was helping human to breathe. There are a lot of challenges in this field. One of the challenges is like synchronization of the soft robotic implant, and then another challenge is like when you have an organ and you want to assist the whole organ, you basically need to meet the rhythms. And she also built sort of a physical twin and augmented heart, where she can study the pathological diseases of the heart based on real data and actuations. And then she did a lot of validation analysis and simulation for her results. So the important thing is like the blood in the heart should be ventilated and should not be cluttered inside the body. So the velocity field of the fluid is very important, and she did it in simulation. Another speaker is like Guangmin. He moved out of the. So we all know that the school fish like self-organization played important role, and we get inspired from the self-organization for the last 2 decades. But Guangmin decided to move on, and he decided to control the living school of the fish. So he designed the robot, like biomimetic underwater robot, the fish-like robot from the scratch. He built the actuation based on the neural circuits for the natural motion patterns. He embedded sensing using the lateral line. He did communication between fishes, and finally he applied this concept, and he achieved some progress in controlling real fishes. So, but we still don't know, like, if the fish is just curious about the robotic fish or the fish is engaging in communication. It still needed to be answered, but we can clearly see that robots are becoming a part of bioecosystem. So we did a quite good progress in this thing. So next thing, like Cecilia Lasche, she presented quite many important ideas. One of the ideas is like related to the impact. The impact can be different, but like how do we contribute to the our ecosystem, and how sustainable are our robots? So she thinks that one of the important aspect is that soft robotics and embodied intelligence can help us to be more sustainable. And then another way to make impact is to make soft robots more robust, and it can be applicable in various applications, like, for example, medical robotics. For that purpose, we need to understand how it works, and the equations and the theory is important. So she made the very famous equation that explains the embodied intelligence for soft robots. Yeah, and then so she basically decomposed the problem into to in-body modeling and to the modeling of the environment, and she incorporated it to the unified theory. Yeah. So Micharet presented control of soft robots. She is working on the reduced model controllers, and she is focusing on stability. She is trying to push the research in soft robotics into more applicable manner, and so it can be applied for many applications. So she is also working on the shape memory based actuations and origami robots, and she is trying to take advantage of the morphology and for improve the stability of the robot. But here we have another opinion. Do we really need to have a precise position control, and do we need to estimate the precise position of the soft robots? So Andrew was questioning, and then he was trying to visit the problem about robustness of the control and the scalability, as well as safety of the interaction. So the general idea is that we can push the high level control to the AI level, to the level of the brain or controller, and to let the body do the low level job. So the synergy of AI and AI was emphasized by the Andrew's talk. Our next speakers were focusing on the environment. Tatsushi was saying that actuations are adaptive to the environment. So he gave us example of the beetle, that beetle changes its behavior based on the environment it has. So if we flip beetle on its back, it will try to use the environment. Even unseen objects that are not natural for this animal are helpful to flip over. Then emergence of exploratory behavior. So so for certain tasks, like the exploratory behaviors are emerging. So he also gave us several bio-inspired examples. Another idea was like body is a medium enabling exploratory activities. So he gave us example with the spider, how the net of the spider can how the spider can change the tension of the net to sense praise. Another approach was the way of so environment is the way of control of self-organization. So by alternating the magnetic field, Jake can propel robots in use self-organization for navigation. So he basically made various type of robots that can do some locomotion, crawling, or even propelling. And he was also controlling the head of the needle to navigate it to certain location. Kristen, she was using environment as a medium for communication of self-organized robot. She showed an example that robots, they don't really need to communicate to each other, but they can use the environment for the coordinations. She also gave some examples about physically mediated coordination and collective behavior of and swarm intelligence in general. So the third group of speakers basically try to focus on the social aspect and social and mental and mind aspects of the interaction. Tom started from the problem, from the symbol grounding problem, whether it's solved or not. So this question seems to be solved a while ago, but now it became really important due to autonomous robots and autonomous vehicles. The problem is that intentionality of the mind and intentionality of the behavior is two different things. And the human seeing the robot like human like robot or vehicle like autonomous vehicle have certain expectations, and these expectations can be different from the ability of the robot, from the way it perceives, the way it actuates, and it can lead to severe problems. And he raised the problem of uncanny valley problem. So there was a lot of discussion about the cartoons, which cartoon is like more plausible, like Tom and Jerry, or more human-like, but still not as close to human to pass the uncanny valley. Why it happens, we can see from the talk of of Rachel Jack. She presented some cultural differences and the real relation with like a facial expression. So her argument was that there is no universal model, and we have like a wide range of signals. We have a lot of muscles and a wide range of signals to express our emotions on the face. And the facial expressions are dynamic in nature, which makes it even more difficult to analyze. So she took advanced approaches for studying the facial expressions. She basically simulated various faces, and she took reverse correlation approach and data-driven techniques for her studies. And then she discovered the dynamic nature and importance of temporal patterns and temporal features in the facial expression. So that's what we really need to replicate if we want to pass uncanny valley, and if we want to make robot more socially plausible and interactive. David Scaramuza, he wants to, he has a clear goal. He wants to beat human in drone racing competition. It's in this case, like a human is like a reference, because it's difficult to build to beat human that have certain internal model, certain perception, and basically we need to improve the drones from various aspects in this case. So he basically built the optimal controller, and he compared to the performance of the human, and he found out that human performs much better. So it means that yeah, so the robot should really learn from the environment and do it in the reinforcement learning way. Then he training the robot is a bit difficult in the real environment. So he was solving a lot of problems in the simulation, and he basically showed that he did a lot of contribution in simulating the natural dynamics, natural dynamics of the an event-based camera thing. So yeah. So today is the second day, and we will start our plenary talk with Odd Beard is our first speaker. She is joining us from EPFL Switzerland, where she leads Learning Algorithms and Systems Lab. We know Oda for contributing in imitation learning. They won numerous of prestigious awards. Today, Professor will talk about human-inspired dexterity and reactivity.